So in today's lab, we're going to show you how to configure IPSEC tunnels on Juniper SRX Firewalls. So the lab is pretty basic. As you can see, we've got one PC here. It's got an IP of 192.168.10.10. We've got another PC here with an IP 192.168.20.10. And these are separated by two SRXs. Now, if we have a look at our SRX config here, there is literally not much going on here. We have GE000, which is which has an IP of 10.10.10.1/30, so it's that interface there. And then SRX2 has the corresponding IP of .2. Then GE001 has an IP address of 192.168.10.1, and that'll serve as the gateway for this PC. So that is on GE001. Now, if we have a look at the config on SRX2, it's going to be identical. Just to show display set. And here you can see we've got the 10.10.10.2/30 on GE000. And then we also have GE001, which is the gateway for this 192.168.20.0/24 subnet. So we've got .1 configured there. Then I just have two security zones. So I've got a LAN security zone where the interface connecting to the PC is attached to. And then we have a public zone, which is the interface connecting to the other SRX. Right, so it's not a very complex setup here. It's just these two SRXs. And the goal of today's lab would be to configure an IPSEC tunnel so that these two PCs can reach each other. Right, so let's get to it. So first we'll start off with SRX1. Now, IPSEC config can be pretty confusing. It's quite a lot of config, and at first it might not make a lot of sense, but as you work more and more with it, it'll actually start making more sense, and it'll become a little bit easier. Just so you know, all these commands that I'm typing, I don't remember them off by heart. So I also sometimes have to reference existing configs. So the best thing for you to do would be to actually just create a IPSEC tunnel template, which you can just quick reference for whenever you need to set up new IPSEC tunnels. So IPSEC tunnels, or VPN tunnels, site-to-site VPN tunnels specifically, they come in two phases, right? So you've got IKE and you've got IPSEC. So IKE is Internet Key Exchange, and that is typically referred to as phase one. So we're going to edit security IKE. Right, so the first thing we need to do is we need to configure a proposal. So the proposal will have your authentication method, your Diffie-Hellman groups, your authentication algorithms, encryption algorithms, and then the lifetime for the IKE. In this lab, we're going to use a pre-shared key. So what I'm going to do, I'm just going to edit proposal, and I'm going to give it a name. In this instance, I'm just going to name it lab proposal, like such. Right, and if we do a set here, you'll see that there's not a lot you can configure here. As I said, these VPNs can be quite a little bit complicated to configure, because you need to configure a proposal, you need to configure a policy, and you need to configure a gateway, and that is just for IKE. Then for IPSEC, you need to configure a proposal again, a policy, a VPN, and then you also need to configure your security policies. Right, but I'm going to configure it from the top down, and I'll explain exactly what I'm doing. So first we're going to specify the authentication method. So authentication method, in this case, we are going to use pre-shared keys. Right, so pre-shared keys is just any text that you want to use as a password. Right, so it's going to be pre-shared keys. Then we are going to configure the security Diffie-Hellman group, or DH group, as group 2. Right, so we can just go to set DH group, and if you do a question mark here, there's quite a few options there. Generally, we use group 2 unless specified otherwise. You can go read up on the different groups. Some of them provide better security than others, but in this lab, we are just going to use group 2. Next, we're going to specify the authentication algorithm, set authentication algorithm, and if you do a question mark, there's quite a few options here. So MD5, SHA-1, and 256.384, that's just the bit encryption. So we are just going to use SHA-1. So if you just want to set up a basic IPSEC VPN with a little bit of encryption, doesn't really matter which one you use here, as long as it matches both sides. All of these are quite secure. There are some companies that if you set up an IPSEC tunnel, they want it to be as secure as possible. So before you configure a VPN for any companies, you just need to make sure what their requirements are. They would usually tell you to use Diffie-Hellman Group 14 with a SHA-384, even higher. Just make sure that your security settings here correspond with what the customer requires, and then also that it matches both sides. Right, so now that we've got the security or the authentication algorithm as SHA-1, we are going to set encryption algorithm, and for this we're just going to use 3 days CBC, or more commonly referred to as triple days. Right, and we're going to specify a lifetime, so set lifetime in seconds. So I'm just making this 86,400. This is the time it'll take before this IKE will try to refresh the connection. So the shorter you make the time, the quicker the connection will refresh and rekey. So just make sure that that also matches with your requirement. Right, now that we've got the proposal out of the way, we can go up and we can go edit policy, and we are just going to name this policy lab_IKE. All right, so once again, we can just set mode main. So if we just do a question mark here, you'll see that you have aggressive and main. So we use main whenever we have static IPs on both sides. If one side has a dynamic IP, then you would use aggressive. All right, so just set mode main. Now we're going to set the proposal. So set protocol proposal, and once again, if you press question mark here, you can do a proposal set, or you can specify a proposal. Now if you specify a proposal set, right, there are pre-configured proposal sets that you can use, and this comes in quite handy if you are a little bit confused and you don't want to configure your own proposals. These would contain predefined parameters. For instance, what we configured in the proposal for the lifetime second and the authentication algorithm, the Diffie-Hellman group, etc. And it's got a few configured there. So if you configure a proposal set as standard on both sides, they will negotiate between each other on the first one that matches. Now you need to make sure that if you use a proposal set, that the proposal set parameters actually match on both sides. So luckily in this scenario, we've got 2 SRXs and the proposal sets are the same. It might not be the same for when you want to configure a VPN between a Juniper and a FortiGate or a Cisco ASA. So for this, we are just going to configure our own proposal. Right, so remember we configured our proposal, lab proposal. So we are just going to specify our lab proposal here. Right, and then we also need to configure our pre-shared key. So for that, we just set pre-shared key, and here you can just type in or select ASCII text, and you can type in, for instance, 1, 2, 3, 4, 5, 6. Okay, and this just needs to match on both sides as well. That's just the authentication password, if you may, for these two devices to be able to communicate with each other. Right, and that would be all for our IKE policy. We can go up again, and now we need to configure a gateway. Right, so we set gateway, and I'm just going to name this one lab_GW. Right, so I'm just going to go into edit here so that we are in the correct stanza. And for this, we are going to select which policy or which IKE policy we would like to use. So set IKE policy, and we're going to select the one we just created, which is lab IKE. So we can just do that. Now we need to specify the remote address. In our case, it'll be 10.10.10.1. .2, sorry. .1 is the local SRX, and .2 is the remote SRX. Right, and then you also need to specify which interface to send these packets out of. right? So which interface would be responsible for initiating the IKE tunnel? So set external interface, and for this we are going to use G000.0. Remember, that is the one connecting to the other SRX. Now if we just go up into IKE and we can do a show. So this is what we've configured. Our phase 1 is now complete. You can pause here if you want to verify anything. I'll just do a show display set, no more as well, so it's a little bit easier to understand. But here you can see we've got our lab proposal. Then in our policy we select the lab proposal, which we've configured here, and then in our gateway we configure the lab IKE policy, which we've configured here. Right, so this is it for phase 1. Now we need to configure phase 2. So we're going to edit IPSEC. Right, so now we are going to do more or less the same. We're going to start off with a proposal. So we do edit proposal, and this one I'm just going to name lab proposal as well. It might be a good idea to differentiate between your IPSEC proposal and your IKE proposal. It is differentiated in the config, but you can maybe just name this one lab proposal IKE and this one lab proposal IPSEC. All right, but just for demonstrative purposes, I'm just going to name it lab proposal. Now, if we do a set question mark, there's quite a few things that you can configure here, and you're going to get confused if you don't know what they all mean. But it's pretty much the same as with the proposal for the IKE. The parameters need to match both sides. So I'm just going to run through some basic parameters that I configure in the lab here. So we'll first start with the protocol. All right, so we're going to set protocol. And if you do a question mark, there's AH and ESP. We're going to use ESP. Then we can do authentication algorithm. So once again, you've got authentication algorithm, the same as in your IKE proposal. This one doesn't need to match the IKE one, but it needs to match the IPSEC proposal on the other side. All right, so do a question mark. And for this one, I think we'll just use HMAC. Doesn't really matter too much. We'll do the HMAC SHA-1 96, right? So it's not really important for the lab, just as long as they match both sides. Right, and then we'll select an encryption algorithm again. So set encryption algorithm, just showing you all the options here. And for this, we'll do AES 256. Right, so CBC. Right, and now we'll have lifetime seconds once again. Now, this is pretty much the same as the IKE lifetime seconds. This will just have the IPSEC tunnel rekey every set amount of time. All right, so we'll do set lifetime seconds, and we'll make this one a little bit shorter. Okay, 28,800. Now, you can also specify lifetime kilobytes. So if we do lifetime kilobytes, this means that this amount of traffic, or after this amount of traffic has traversed the IPSEC tunnel, it'll renegotiate phase 2. Right, so you don't have to specify that. I'm just going to make it 4608,000 just to give you an example here. And now if we do a show, that is our lab proposal for phase 2 complete. Right, now we need to configure a policy again. The same as with the IKE policy, you now have to have an IPSEC policy where you're going to reference the proposal you just configured. So we'll just set policy, we'll make it lab underscore IPSEC, right? And we're going to specify the proposal, and we are going to use lab proposals, lab proposal, right? That's all you need for your policy. Right, and then lastly, we are just going to configure our VPN, right? So under edit IPSEC VPN, so we just go edit VPN. We'll give it a name, lab underscore VPN, Right, so you can see there's nothing configured here. So we'll actually start off with the bind interface command. So set bind interface. Now here you're going to use st0.0, okay, or any st0 dot whatever interface. We'll start with st0.0 because that's the first ST interface that we have available. ST is a secure tunnel interface, and it'll always be ST0 and then followed with a logical number. All right, so set bind interface st0.0. Now we're going to set which IKE gateway to use. So set IKE gateway, and we are going to reference the lab gateway that we configured earlier. Okay. Now we're going to configure the policy to use, the IKE policy to use. So set IKE policy, and for this one, typo, and for this one we are going to use set IKE IPSEC policy, and we are going to specify the policy that we've created. So it's going to be lab underscore IPSEC. Right, now I know it's a little bit confusing. We'll go over the config just a little bit later as soon as we've done with the config here. Right, and next we will start configuring the traffic selectors. Right, so there are multiple ways of defining the local and remote subnets that you want to access via this IPsec tunnel. Juniper actually didn't support traffic selectors up until pretty late. I think it was 2016 or 2017. Previous to that, you actually, or prior to that, you had to use proxy identities, or you needed to use policy-based VPNs. Policy-based VPNs, just a different beast. It's quite complex, quite complicated. So we'll use traffic selectors, and I'll show you exactly why we use traffic selectors in the next part of the config. Right, so we'll just set traffic selector, and here you'll give it a name. So I'm just going to name it lab TS underscore TS1, right? So this will be my first traffic selector, and you're going to say local IP. Now, the local subnet that we want to access is 10.0/24. Now you're going to specify your remote IP, and in this case, it's 192.168.20.0/24. So the main reason why you want to use traffic selectors is because you can actually specify multiple traffic selectors. If you want to use proxy identities, then you need to configure phase 2 VPNs or IPsec VPNs for each local and remote subnet that you want to use. With the traffic selectors, you can specify multiple traffic selectors. So if we do a TS2 local IP, I'm just going to 0000/0 just to give you an example. We'll do a remote, and we'll also make it say 1.1.1.1/32, for instance. And if we do a show now, you can see that we have 2 traffic selectors in this VPN. And the last config statement we're going to make is set establish tunnels immediately. Right, so this means that the tunnel would always be up, even if there's no traffic flowing through the tunnel. This is also environment specific. Some opcos that we work with, they're eNode Bs or base stations. If you configure the establish tunnels immediately statement, the traffic actually doesn't work properly. So if you don't have this statement configured, then the tunnel will only be established once it senses that traffic needs to traverse the secure tunnel. Right, so for in this lab, we're just going to use establish tunnels immediately. This will be the majority of use cases, especially for enterprise VPNs. Just configure establish tunnels immediately. Right, so if we go back into our IPsec, we'll do a show display set, and you can just have a look at all our config to familiarize yourself. But just to run through it, we've got our lab proposal that we configured. Then in our policy, we reference the lab proposal. Then in our IPsec, this is where we reference the gateway that we configured, the IKE gateway, and we configure our traffic selectors, which contain our local and remote subnets. Right, so that's pretty much it for your IPsec config. There is one more thing that you need to do. So if you remember, we have st0.0 configured in our IPSEC tunnel. So the next thing, or the last thing you need to do for this specific VPN is set interfaces st0.0 family inet. Right, so now if we do a show pipe compare, this is all the config that you would need for your IPSEC tunnel to come up. Well, almost. Right, so remember this is a security device. So if we have a look at our security zone, we have our public here, and you can see that we allow ping, right? So that is just for SRX2. We'll do run ping 10, 10, 10, 1. So so that it can ping it, but it does not allow anything else incoming on this interface. Right, so we need to set public, set security zone, public interface GE000.0, and host inbound traffic system services IKE. So we need to allow internet key exchange messages on this interface. Right, so if we do a show now, this is what our public zone looks like, and we can go ahead and do a commit. It should go through. And once it's gone through, now you can actually start working on your security policy. So type edit security policies. I have no security policies here. So I'm going to allow traffic from the LAN to the VPN and vice versa. All right, so I'm first going to create our zones here. So we have, let's just go edit security zone, edit security zone. Right, so we have our LAN and we have our public, but we don't have a VPN. So we're going to edit VPN, edit security zone VPN, and we are going to set interface st0.0. All right, let's just make it host inbound traffic system services all. Let's just do a show, and that's what we've got there. So we'll go up here and we'll go into edit policies, right? So edit security policies. So we say set from zone LAN to zone VPN. I'm just going to name it permit all. So permit all, match source address. I'm just going to make it any for now. Destination address, any, and application, any. Right. Then we just do a then permit. And now we just need to do the reverse as well. So we'll do a set from zone VPN to zone LAN, and we'll just use the same parameters, right? So we'll permit all, match source address, any destination address, any application, any. And once again, then permit. Right, if we do a show here, now we have our policy from LAN to VPN and from VPN to LAN. This is not a security policy lab. If you want to see how to configure security policies, we also have a video up on that. This is just to allow all traffic for the VPN. Right, so we can go top and we do a commit. Right, so we can do a run show security IKE security associations. There shouldn't be any. And then also run show security IPSEC security associations. And there shouldn't be any. Right, so now we need to replicate this config onto the other SRX. Once again, I'm not going to bore you too much with that. I'm just going to show you what I do. I basically will take all the config here not relating to interfaces. I'll copy it across into Notepad, and we'll just make one or two changes here. So the remote address would change to .1, and we would just swap around the proxy identities or the traffic selectors. Right, and that should be everything. So I'm just going to go ahead and dump it on the other SRX. All right, we've done that. The only thing that we haven't copied across is set interfaces st0.0 family inet. Right, so we can go ahead and commit this, but let's first just do a commit check. Make sure that all the config is there. We can do a show pipe compare. Make sure that we've got all our security IKE, security IPSEC. We've got our security policies, and we have our security zones that are updated with the IKE and the correct interfaces. Right, so we can go ahead and do a commit. And hopefully, if all goes well, we should now have our IPSEC tunnel established. So run show security IKE, security associations. You can see that our IKE is up with the remote address of 10.10.10.1. We can just verify the same on this side, but it should be up. Run show security IKE, security associations. You see that it's up. And we can do a run show security IPSEC, security associations, for checking the phase 2. And you can see that it is up as well. We'll just verify the same on this side. Run show security IPSEC, security associations. Right, and that one is up. So technically, if we go to our PC 10.10, we should be able to ping 20.10. So ping 192.168.20.10. Right, and it is actually working. So let's do a -T here, and I'm going to just go into our topology here just to show you. So what we've done is we've set up an IPSEC tunnel between these two SRXs, and now I'm pinging from this host to this host over that ST0 interface. Right, we can verify that on the SRX as well. So if we do a run show security flow session, we should see traffic between those two hosts on ST0. Right, so it's a source 10.10.10, destination 20.10, and interface ST0. So that all looks correct. So if you're wondering about routing, how do we route between the two sites? Well, that's the beauty of using traffic selectors. If we do a run show route, you will see that we have a static route for 192.168.10.0/24, which is the subnet on the other end connected to SRX1. And you can see that it's a static route via ST0.0. Now, if we go into top edit routing options, static, we do a show there's no static routes configured here. So what actually happens when you use a traffic selector, let's go if we go top edit security IPSEC, we do a show, it would actually automatically create a static route for this remote subnet as soon as the VPN comes up. So then just the last thing that I want to show you. So for instance, if we go onto this SRX here, if we capture a packet on GE000, you'll see that the traffic is actually encapsulated. We can go ahead and stop this. So if you try and open up and inspect this packet, there's nothing much that you can see. All you can see is that the source is 10.10.10.1 and the destination is 10.10.10.2. So it's SRX1 going towards SRX2, and there's the reply, but it's protocol ESP, right? And everything is encapsulated in a security payload here, right? You won't be able to see anything in this packet. Our original source and our original destination is hidden from view. This is only the SRX IPs. Now, just to show you what it looks like if we compare it to once it's been decapsulated or de-encapsulated or unencapsulated. I'm not sure exactly what word to use there. So for that, we'll just capture a packet on the outbound interface, right? So which is GE001. And you can see once it's not traversing the security tunnel or the secure tunnel anymore, the IPSEC tunnel, you can actually inspect the traffic, right? You can see it's an ICMP message. We've got our sources and destinations, the correct source and destinations, and the protocol in here. Right, and that's it for this video. I hope you guys enjoyed it. If you did, hit that like button, hit that subscribe button, and as always, we hope to see you guys in the next one.